करना चाहूँगा कि अपने स्टूडेंट, इवन पास आउट स्टूडेंट को भी इंटर्नशिप हमारा जो पोर्टल है उसमें जाके उनको रजिस्टर करने बोलिए। इफ स्टिल दे आर पास आउट स्टूडेंट इज नॉट एम्प्लॉयड, और जो करेंट स्टूडेंट है उनको तो जरूर जाना चाहिए, क्योंकि इंटर्नशिप इज अ मैंडेटरी फॉर बीटेक स्टूडेंट। अराउंड 700 आवर्स दे हैव टू कंप्लीट, दे हैव टू टेक अ प्रैक्टिकल ट्रेनिंग, एंड डिप्लोमा के लिए 500 आवर्स का होना चाहिए इन 6 मंथ। So I request to all the faculty member, kindly motivate to the student to register in internship portal। वैसे ही एक नीट प्लेटफॉर्म बनाए हैं। नीट प्लेटफॉर्म क्या है? नीट प्लेटफॉर्म एक स्किल बेस्ड, जैसे आज हम अटल कर रहे हैं उसमें बहुत सारे ब्लॉकचेन है, आर्टिफिशियल इंटेलिजेंस पे बहुत जगह हो रहा है, तो वैसे बहुत सारे इमर्जिंग एरियाज है, उसके बेस्ड पे एक स्किल प्रोडक्ट बनाया है, दैट इज पेड प्रोडक्ट। तो नीट में जो रजिस्टर करेगा उसको पे करना पड़ेगा, कहीं कहीं पे कुछ कंसेशन है। और अगर ये पेड प्रोडक्ट को से अगर आप स्किल लेते हैं, चाहे फैकल्टी हो चाहे स्टूडेंट हो, तो स्टूडेंट लेते हैं तो उसके लिए क्या है कि ये दैट विल बी ट्रीटेड एज ए इंटर्नशिप। तो इट इज अ बेनिफिशियल, अगर आप करते हो तो स्किल का स्किल और आपका इंटर्नशिप प्रोग्राम भी इसमें कवर हो जाता है। दूसरा स्मार्ट इंडिया हैकाथॉन के बारे में पहले ही बता चुके हैं सर ने, मैंडेटरी एक्रीडेशन के बारे में भी बता चुके हैं। इसके अलावा छात्र विश्वकर्मा अवार्ड है, छात्र विश्वकर्मा अवार्ड और उत्कृष्ट संस्थान अवार्ड, दिस इज आल्सो पार्ट ऑफ क्वालिटी इनिशिएटिव्स। और सबसे खास बात यह है कि हर एक कॉलेज में इनोवेशन, रिसर्च, स्टार्टअप, इंडस्ट्री रेडीनेस सेल, ये सारे होना चाहिए, ऐसा हमारे AICT के अप्रूवल प्रोसेस में प्रोविजन है। उसका रिजल्ट क्या हुआ है कि 2016 में हमारा जो इंडिया था, दैट वाज 84 रैंक इन इनोवेशन एंड रिसर्च एरिया में इन द वर्ल्ड। नाउ इट इज शिफ्टेड टू 48, तो दैट इज वेरी मोटिवेटिंग फॉर अस। अब सर ने जैसे बताया, हमारे सर ने कि पर्सपेक्टिव प्लान डॉक्टर रेड्डी ने बनाए हैं, ने दिया। पर्सपेक्टिव प्लान में ये कहा गया है कि ट्रेडिशनल प्रोग्राम को अब अप्रूवल ना दिया जाए और इमर्जिंग एरिया को दिया जाए, क्योंकि इंडस्ट्री 4.0 में जो चाहते हैं वो इमर्जिंग एरिया में जो टैलेंट है वो आना चाहिए। तो दैट्स व्हाई वी आर ट्राइंग टू क्रिएट अ डिजिटल टैलेंट थ्रू आर्टिफिशियल इंटेलिजेंस, IoTs, डेटा साइंस, ऑगमेंटेड रियलिटी एंड वर्चुअल रियलिटी, क्वांटम कंप्यूटिंग, इन सारे पे, रोबोटिक्स, ब्लॉकचेन पे आप करवा ही रहे हैं। तो इन एरियाज पे इस पे काम होने की जरूरत है, फैकल्टी ट्रेन करने की जरूरत है, अल्टीमेटली स्टूडेंट को ही जाना है, which they are our main stakeholder. Again, I will repeat, because all the times in a WhatsApp and other thing, I observe that nobody is talking about student, because and they are talking about their faculty or institution related. So we should talk more about the student, because students are a more stakeholder. We should always try to think how to give benefit to the students. सो एज पर पर्सपेक्टिव प्लान, ये 2017 से चालू हुआ हमारा अटल, और अब इस साल का हमारा टारगेट है 1 लाख फैकल्टी मेंबर को हमें ट्रेन करना है इमर्जिंग एरिया पे, और 562 ऑनलाइन FDP कराना है। तो हमारे सेंट्रल रीजन भोपाल को अभी टारगेट मिला है 62 फैकल्टी प्रोग्राम करवाना है थ्रू अटल के थ्रू, जिसमें अभी करेंटली 36 हो चुका है और 22 अभी चल रहे हैं। तो मैं आप सभी से अनुरोध करना चाहूँगा कि आप ज़्यादा से ज़्यादा अटल का पोर्टल विजिट करें, आप फैकल्टी को मोटिवेट करें, ज़्यादा से ज़्यादा इसमें रजिस्टर करें और इसका लाभ उठाएं। इसी के साथ मैं आप सभी को इस वर्ष आपके लिए शुभकामनाएं देता हूं। वंस अगेन हिंदी दिवस की शुभकामनाएं, शिक्षक दिवस की शुभकामनाएं, और मैं आशा करता हूं कि LNCT जो है अभी टॉप इन दिस स्टेट है। मैं उम्मीद करता हूं कि आने वाले दिनों में ये हमारे इंडिया में भी टॉप 10 पोजीशन में जल्दी से जल्दी पहुंचे। थैंक यू वेरी मच।
बहुत बहुत धन्यवाद सर हमारा मार्गदर्शन करने के लिए। Now I request Shri Narain Choksey sir, Chancellor LNCT University and Chairman LNCT Group of Colleges, who is the constant source of inspiration behind everything, to bless all of us with his words of wisdom.
अटल एडीपी के ये एकेडमिक द्वारा चलाए जा रहे ये एडीपी कोर्स में मैं आप सबका हृदय से स्वागत करता हूं। वर्मा जी, राजीव जी और कांतव जी और संस्था के सभी प्रमुख व्याख्यातागण और जो आज इस सेशन में शामिल हैं, उन सबको मैं स्वागत भी करता हूं और चाहता हूं कि आज इंजीनियर्स डे पे जो एक नई शुरुआत की है एलएनसीटी ने, वो एक मील का पत्थर बने और लोगों के सामने उदाहरण बने कि एलएनसीटी पूरे नॉर्थ इंडिया का फर्स्ट प्राइवेट इंजीनियरिंग कॉलेज बना है, हर चीज़ में फर्स्ट हो, यही हमारी चाहत है। और इसके लिए हमारे एलएनसीटी परिवार के सभी सदस्यों ने पूरी तन मन से जो काम किया है, मैं उनको सबको हृदय से धन्यवाद भी देता हूँ और उन्हें एलएनसीटी को बढ़ाने के लिए जो काम किया है वो वाकई बधाई के पास है। वर्मा जी, आपने हमें हर तरह से सहयोग किया, उसके लिए मैं आपका हृदय से धन्यवाद करता हूँ। राजीव जी ने भी हमेशा एलएनसीटी को प्राथमिकता दी है, उसके लिए मैं उनका धन्यवाद करता हूँ। मैं इस कार्यक्रम की सफलता के लिए सभी को धन्यवाद देता हूँ और उम्मीद करता हूँ कि ये कार्यक्रम शिक्षकों के लिए एक बहुत विशेष महत्व का होगा और वो शिक्षक इसका एक बहुत बड़ा लाभ लेकर अपने जो अपने करियर को एक नया आयाम देंगे। धन्यवाद। जय।
Thank you, sir. Thank you very much. Now I request Dr. Ashok Kumar Rai sir, Director Administration, LNCT Group of Colleges, to kindly present vote of thanks.
Good morning, everyone. Good morning, everyone. आज के इस कार्यक्रम माननीय राजीव कुमार सर, मेंबर सेक्रेटरी आईसीटी, जिन्होंने के अपने इस कार्यक्रम में पधारकर बहुमूल्य समय देकर हमें अनुग्रहित किया, मैं आभार व्यक्त करता हूं उनका। माननीय सीएस शर्मा सर, सीआरओ आईआईटी भोपाल, इस कार्यक्रम में पधारकर पूरा एफडीपी के बारे में और एजुकेशन रिफॉर्म के बारे में विस्तार से समझाया, मैं उनका बहुत बहुत आभार व्यक्त करता हूं। आदरणीय जैन चौकसे सर, चांसलर एलएनसीटी यूनिवर्सिटी, चेयरमैन एलएनसीटी ग्रुप, जो कि एक नई सोच, नई दिशा में अग्रसर करने के लिए, नया करने के लिए हमेशा सभी को मार्गदर्शन देते हैं, मैं उनका आभार व्यक्त करता हूं। एनर्जेटिक सेक्रेटरी युवा श्री अंतोन चौकसे जी का भी मैं आभार व्यक्त करता हूं, जो कि इस काम को आगे बढ़ा रहे हैं और एलएनसीटी परिवार में मोटिवेशन के कारण हम लोग आगे बढ़ रहे हैं। मैं सभी प्राचार्य, डायरेक्टर्स, ओएसडीज और इस कार्यक्रम में कोऑर्डिनेटर श्री अनूप चतुर्वेदी, विजय त्रिवेदी और सभी स्पीकर्स, पार्टिसिपेंट का आभार व्यक्त करता हूं और जो इस कार्यक्रम में मैं प्रेषित करता हूं। धन्यवाद।
पता नहीं कहीं होगी।
सुदेशना मैडम आवाज आ रही?
सुदेशना मैडम,
हेलो
जी सर, आ रही है आपकी आवाज।
जी, आप कंटिन्यू करें, खत्म।
जी जी सर। सर अनूप सर कुछ अनाउंसमेंट कर रहे हैं।
जी जी।
Now I request to all the participants kindly be connected, and all those who have not participated in that FDP can leave the meeting. The session will start from 10:50 within 5 minutes. Our expert have to connect it. Okay, thank you.
CS वर्मा सर नमस्कार सर, थैंक यू वेरी मच सर
हाँ,
आपको।
नमस्कार सर, आप सभी को नमस्कार। आपने हमें बुलाया इसके लिए धन्यवाद।
थैंक यू मैं भी
Now our expert,
Hello.
Dr. Neminath is joined. Hello, good morning, sir.
Good morning. Good morning.
Yeah. Please come and
Hello. Good morning. Good morning to all of you.
In today's faculty development,
Have a little problem with audio.
good morning
Uh,
to all of you.
yes, slightly.
Hello, I'm audible.
Yeah, little. It's better now.
Okay. Good morning to all of you. Hello,
Hello.
I'm audible.
Yeah, madam, it's breaking. Am I audible? Hello, madam. Hello.
Hello, I'm audible.
Yeah, little bit. Am I audible, madam?
Yeah. Hello. Today, faculty development program. We are privileged to have Dr. Neminath. I'm audible, sir.
Yeah, little bit, but still it's breaking. I don't know, maybe my internet connection. Hello.
Hello. Good morning.
Yeah, it's slightly better.
Hello, sir. I am audible to all.
Yeah, I can hear you slightly better. I don't know about my voice. Are you getting my voice properly?
Yes, ma'am.
Hello, everyone.
Sir, I am audible to all.
Yes, we can hear you.
Okay, sir. Good morning to all. In today's FGV development program, we are privileged to have with us Dr. Neminath. Good morning, sir. Dr.
morning,
Neminath is Associate Professor in Department of Computer Science and Engineering in IIT Indore. He has done his PhD from the Department of Computer Science and Engineering, IIT Bhopal. His research work is mainly oriented in field of network security, system security, IoT, and fault detection in Internet. He has many publications in international and national journals of physics. Apart from, he has presented many papers in international and national conferences. It is my pleasure to invite such an eminent personality, Dr. Neminath. Welcome, sir, to this session of FDP. So please carry on the session. Start your place.
Yeah. Thank you.
Okay, thank you, sir.
Yeah. Good morning to all of you. Is my voice audible?
Yes, sir, audible.
Okay, fine. Thank you. So is the screen now audio you can see? Okay. Yeah. Fine, thank you. Let me okay. I hope now screen is visible to everybody. Once again, good morning to all of you, and thank you for inviting me to give the inaugural session on this FTP program. So the next I will be talking about development of blockchain technologies. This is what the outline of my talk goes. So all along while talking about blockchain, I also touch upon a little bit about the cryptocurrencies, and then because blockchain, the very first and the clear application that came is about the cryptocurrency. So let's discuss how cryptocurrency and blockchain are related, and what are the other applications, and the security issues of the Bitcoin, and then how the technology itself as a Bitcoin can change the future about communications and several applications, the way it's been handled. So that's what roughly I'll talk about in this session. Let's start with the primary question by asking what is a currency. Here I put a nice 2000 rupees note, and then it's a Indian currency by Reserve Bank of India, and so we all accept this as a currency for our day-to-day whatever purchase selling that we do. So what does this currency actually means? It's actually a piece of paper, and what is written on this note is something which is very interesting. So you can see this is signed by the Governor of Reserve Bank, and it says, I promise to pay the bearer the sum of 2000 rupees. So call up any note you open, then whatever the denomination of that note, based on that this is written. So what it means is, I promise to pay the bearer. Who is the bearer? The one who is holding this note, a sum of 2000 rupees. So that in turn essentially means that this itself is not 2000, but whoever holds this note will be can get something worth of 2000 rupees. So I am actually going to pay them anything which is worth of 2000 rupees. That's what it says. So the nice distinction between this currency and the one is, so this is actually a note, but not the actual money that, So, but for the easier transaction, we all accept because it is backed by government agencies like RBI, and if you take other countries, the other similar notes should be there. So that's how we do day-to-day transactions, give and take, whatever we do in our life. So let's try to understand the subtle difference between money and currency. Currency is, and of course they are not the same. Currency is a legal tender. So whoever brings that currency, so we, based on what is the face value of that currency, we accept that for the equal amount of money. So it's based on some sort of trust information, because the government says this is the legal tender, and the RBI says this is the legal tender. And the currency can be in many formats. So it can be minted coins, 1 rupee, 2 rupees, 10 rupee, whatever coin we have in the market. So the paper money, the one example that I showed in the previous slide, can be example of currency. And surprisingly, even the letters of credit, which maybe all of us know after the PNB episode, these letters of credit which banks issues are also some form of the currency, because bank is telling you this letter of credit is worth of this much amount, and whatever amount is printed in the letter of credit, so it's exchanged basically for that amount. And some kind of whatever bank says this is the quantum of amount in your account or that, those are all form of a currency. So the fundamental difference is money and currency are not the same thing. And at any point of time, the quantum of the currency that is there in the market need not be equal to the quantum of the money that somebody has. So for example, if I have 1 lakh rupees in my bank account, so that 1 lakh rupees I don't have to have that in the currency format. So neither the bank need to store that 1 lakh rupee worth of currency in its treasury. So these two are different. So currency is basically mean to facilitate the day-to-day transactions, something when we buy, give and take, but that's not the money we have, and it can take many formats. So let's understand how the financial transactions happen in today's banking system. Take any bank example, for example, the biggest bank SBI. So all of us hold an account in that bank, and the bank maintains the bank balance amount in my account, your account, and somebody else's account. So here is an example of the underlying technology that is there in the bank's database. So this is a distributed database, meaning that it's basically a relational database. If all of you are, I hope all of you are from computer science background. So this is a relational database. All of us understand what is a relational database, and it is distributed in nature, meaning that the database itself is not in one place. It is in multiple places. So multiple places not necessarily mean that they are geographically apart. Even the servers were next to each other, 1, 2, 3, 4, all of them in being in the same place, it is also a distributed database. But to be honest, this is not how the distributed database, particularly banking systems, have maintain their databases. They actually have the databases distributed across the geographies also. So for example, the main data center of the banks might be in Mumbai, and a replica of that might be in Kolkata. And every transaction that I do will be first done it in the Mumbai server, and a copy of that will also be sent as a backup to the Kolkata. So it need not be only one backup server, multiple backup servers can also be there. So you can even designate more than one server as a primary server for load balancing purposes, and then some of them are in the backup. So what is there in this database? Every user, every account holder details and the quantum of money that he holds or she holds, those things are maintained. Here I have shown, for example, 3 servers. All of them are connected through one communication medium. Here I have shown a switch, but not necessarily through one switch. So if they are geographically apart, they might be connected over the internet through VPN and so forth. So there are 2 accounts in this database. One is Alice, he is holding $100, and Bob is holding account 0. It's a 0 account. And if some transaction is done, so the whatever transactions are initiated, those need to be replicated and honored by the bank on behalf of the end users. Those transactions actually executed by the bank, and then the necessary changes are made to the relation databases. So let's say I initiated a transaction. Alice has $100 in his account, and he wants to transfer $50 to Bob. So how does this transaction gets executed? the very first, the moment I say you transfer $50 to Bob, so what does the bank do? The bank goes and check, the first check is whether $50 is available in his bank account, my bank account, or in this example, Alice bank account, EPS. So next question is whether you are allowed to send that money to Bob, either because of limitations on my bank account or Bob's account. Sometimes they may prohibit if it is for some reasons, and if it is allowed to send the money, then so well checks whether the Bob's bank account number is correct one. So and then decrement the Alice bank balance by 50, and that increment the Bob's bank balance. It was 0, now $50 transferred, so his balance became 50, and now the transaction is committed. These are the sequence of operations that happen. So who does this transaction? On behalf of Alice's instruction, the bank is actually doing this transaction. So this transaction is basically reflected in its back-end relational database. So some SQL queries are executed. So to deduct the money from, update the balance in the Alliance bank accounts, update the balance in the Bob's bank account, and then both of the entire sequence of operations are committed. So you know what is the commit operation? Commit operations is basically when these relational databases, what will happen in the backend. So you bring the data from the secondary drive to the main memory, and then update the things in the main memory, and then flush the contents from the main memory back to the drive. So when that contents is reflected in the hard drive, so that time we see that transaction is committed and it is permanent. So main memory, we all know, if the complete power goes out, the contents in the main memory are erased. So to get a guarantee that the transactions are permanently reflected on the database, we actually do this commit operation. So in this entire sequence of operations, so what is that is happening? So on behalf of the end users, the bank is the one which is doing the entire sequence of operations. So when I say the bank is doing it, there is an inherent trust in the bank, saying that bank will indeed do what I am saying, and there is no chance that either the money from Alice's account is decremented when I am not saying it transfer, or Bob's account money is disappearing from whatever is there. So I trust, you trust, everybody else trusts. That's how banks are running. So this financial transaction basically is based on some sort of the trust, because we trust our government, we trust our banks, we trust RBI, everything is smooth, and we need to do work according to what we say. So that's what this economic situation and everything is running. So after this transaction gets executed, so earlier I had $100 in Alice's account, and Bob had 0, and now because of $50 transfer, this is what the distributed relational database entries look like. So these servers basically contain databases, and that's how after the transaction is executed, database is updated. So this is how we transact in day-to-day activity. Now, what is the issue with this isn't? This is a little bit complex, because when I say the transaction, so if something happens in the middle, transaction is committed, before the transaction is committed, what we need to do, for some XYZ reason, if I decrement the Alice's amount from the relational database, and for some XYZ reason not able to credit to the Bob's account, then I need to go back to a consistent state. So what does it mean? You need to roll back. So whatever deduction I did from the Alice account, that $50 should go back to the Alice account. So either these sequence of operations are executed, or and committed, or as if none of them are executed, we should go back to the previous state. That's when we say that databases in the consistent state. There is no inconsistency. If I deduct the money from the LIS account and fail to credit to the bank, then the transaction is not committed. So money is disappearing in the middle. That should not happen. So that is why it is little complex. Given that the database itself is replicated and they are geographically apart, so the overall exercise of doing this commit operation, because all the databases in the distributed database need to be updated. It's not one. The primary and also the replicas need to be updated. And because of the inherent latency in the transactions that are happening from your account to the account and the load the bank servers need to take out, so this is really inefficient. So they need to invest a lot of computing power to sustain the load that they usually get at a particular point of time. And the most important thing is it is vulnerable in nature. So anything can go wrong at any point of time. So what can happen? So the network can break down. So think of the situation. I'm connected to the local Wi-Fi in my home and doing some transaction. For some reason, suddenly the Wi-Fi connectivity goes down. But I was in the middle of some transaction. At the same time, something wrong and I get disconnected. So now what do we need to do? So again, you need to, the bank need to ensure that whatever transaction that is initiated is either completed or it's not completed. So there is no in-between situation. So this kind of failure can happen anytime. So for example, when I'm saying the primary server database is in the Mumbai data center and the replica is in Kolkata. So when I am synchronizing the updates made on the primary server which is in Mumbai and transferring the content to server in Kolkata, in between some time there might be a network glitch and whatever data transfer that is happening can be incomplete or again resistant, and there might be errors that can be introduced in the transmission. So all of this need to be handled very carefully and gracefully so that so the situation is not unwanted and end users lose trust on the banking system. So that is the issue with the current system. So in all what this money transaction in the trail that is happening, and we trust the banking system to do the right things and make sure that money is not disappearing from the system, what exactly banks are doing or the government agencies like RBI are doing? They solve one technical problem fundamentally, which is called double spending problem. So what does it mean, spending? So if I have 2000 rupees note, the nice currency that I stored, so either I give it to person X or I give it to person Y. I should not be giving that to both X and Y. If I have only one vote, either I can give, basically when I am giving, I can go to X and do a transaction, give it and then buy some items, or I can go to Y and then get some items. But the same note, one single note cannot be given to two persons. But in technical parlance, since I am doing an online transaction, this is basically the same thing. The technical means the relational database, whatever query getting executed in the back end, need to ensure that if I have X amount of money in my account, I should not be spending that X twice time. That is called double spending. So this I should ensure, because that is when I get the equivalence of as good as having 2000 rupees currency note. The same thing what I would have done with 2000 rupees note should be done with the bank balance also, because I am talking in the digital transaction. So by all this means, actually they solve one fundamental problem which is called the double spending problem. So by inherently trusting the bank, we are actually ensuring a faith in the banking system so that the double spending problem is never appears in the system. So unnecessarily bank should not inflate somebody else's bank money so that he actually get to spend more money. That kind of problem happen. So this is technically called double spending, and that never happens in the system. So let's take another example using the credit card. All of us sometime or the other time might have done online transactions using credit cards. Let's say take an example of Amazon.com. And you go and buy some items in the Amazon, and you enter your credit card number. And what will happen? Your credit card details are taken by the Amazon, and then we are verified whether this is a valid credit card. With whom they verify? We will verify with the merchant which issued the credit card to you. It might be your bank, SBI credit card, it may be HDFC credit card. With the bank, go and see this is the credit card number that the end user is giving me. Is it a valid credit card number? So does this user have an account, a credit card account in your system? When the bank says or the issuer says, yes, indeed, this is a valid credit card number, and he is authorized to do the transaction or basically spend this money, and basically every bank issues you some credit limit, 1 lakh rupees per credit card, let's say. Then you are authorized to initiate a transaction up to 1 lakh rupees. So when it says yes, this transaction, this user XYZ is buying items worth of 1 lakh rupees, is he allowed to do this transaction? When the bank says yes, then they will complete the transaction and then send you a confirmation. So in this process, what exactly is happening? So it usually basically compromises your user privacy. So the Amazon get to know what is your credit limit. So when it says, when I'm saying 1 lakh rupees limit, so then based on some other parameters, banks issue the credit limit. If Amazon is getting to know my credit limit is 10 lakh rupees, then I must be a very rich person, or I might be earning a lot of salary, something like that. So it compromises the user's privacy. So that is unwanted. So, and in the process, these merchants usually also store the credit card information. So that actually is also a security risk. On behalf of you, later some point of time, although they don't do this because there are standards imposed how to store this credit card numbers and all in its database and also forth. So, but there is a danger that somebody else who is sharing your credit card number can misuse it. So that's one of the issues. So how does this payment system, let's go back to credit card system banking system evolution. The first online credit card based settlement service was opened by a company called First Virtual. This is actually a mediator service which actually, if I say I am buying some items worth of 10,000 rupees, what you need to do is you send an email to the merchant. They will verify that with the First Virtual service provider, and then confirm that this is a transaction. You can go ahead and issue items worth of 10,000 rupees to so and so person. Once that is confirmed, then the items will come to you. So 1994, back then, the penetration of the internet and all of that was not that good. Basically, in US you had and Europe some very handful number of the computers connected some universities and that. So surprisingly, there was no security found in this first credit card lesson. So you can see that they are settling the transactions by sending emails. So back then, email system itself was not secure. It was all open. You had servers like SendMails and all which are carrying the email information in plain text format. So that was the first system of virtual currency credit card system settlement happened over the internet. Next, somewhere a couple of years later in the 1996, CyberCat, one company came up and it implemented a cryptographic solution for credit card transaction. Basically, they use the public key cryptographic system to do the end-to-end encryption system for the credit card transactions. And then back then in US, it was actually not legal to use those encryption systems outside the US geographical boundary. So they had to face some legal issues to operate in other countries. So basically they did not go out of the system. So finally people found out some weakness in that. Around 2000 they operated for 4-5 years, and then VeriSign actually acquired that company. It went bankrupt and all after facing the legal issues, and somebody found the exploitable flaw in their encryption algorithms. And subsequently, now we are all aware VeriSign, Visa, MasterCard, American Express, all of them, these are some of the companies which issues your debit cards and credit cards to they use them. So this is some kind of history. So the point that I'm trying to make is, so all of these transactions that are happening with some sort of inherent notion of the trust, and these companies in the background are actually doing the verification process on behalf of the end users. So this kind of currency requires some form of the protection against the attackers. So basically, you take the physical currency, it actually means that it should not be easy to print a duplicate currency, so there should be inherent security mechanism. Similarly, if you take the credit card, because I should not be spending more than what my credit limit says. And so if you take the same balance, even the cryptocurrencies also need some sort of the security mechanism, and that is what we discuss, how this blockchain actually helps us to achieve this double spend, how it solves the double spending problem, and also the end-to-end encryption issues, and also the verification process. So let's go and look into some. So after having understood how the typical economy or the current system works, so let's look at what exactly is a blockchain. Blockchain is basically a shared immutable ledger. What do you mean? And this terms. It is shared. Shared means multiple people actually have the copies. Immutable means something which is done once cannot be undone. So what you can do is, if I transfer, let's say 100 rupees to somebody else's account, so that 100 rupees transaction cannot be undone. What can be done is, another 100 rupees can be transferred back from to whom I transfer back to my account, but you cannot erase the trail of what I have transferred 100 rupees to from my account to somebody else's account. That is immutable. It is saved because everyone has a copy. Immutable because transactions once done cannot be undone. And it is basically a ledger. Ledger is basically a book. So I am talking about blockchain as a technology which ensures this. It is saved among all the people, and transaction once done is not erasable by any means. And then it is basically a ledger. Some record would be there in the database. That is what the blockchain is all about. So what it facilitates, it facilitates two things. It allows recording of transactions. Recording transaction, I transfer 100 rupees from my account to account X account. So the trail of this recording, transfer of the money is recorded there in the ledger. And it also shows the tracking of the asset, meaning that here in this case is the money or the currency. So where all the money has gone from X to Y to Z to E, B, C, P, Q, R. So this entire sequence of operations can be traced from the ledger. So that is what the blockchain ensures. So let's see how does it do so. So before we get into this one, there are actually two kinds of blockchain technology. One is called permissionless blockchain. The second one is permission blockchain. So permission blockchain is an open source and open accessible blockchain technology where anybody in the world can install the necessary software and join and become part of the blockchain. The second is some companies like all the users of the some financial system can themselves become part of the, and they have their own ecosystem of the blockchain, and then any user who is getting into the system need to first take the permission of the admin. So then you are allowing that user to become part of that. So this is the permission blockchain. So this is basically within an organization. So for example, the LNC college itself can have its own blockchain, not necessarily to transact the money, but for other reason. You'll see at the end of this what are the clear applications of the blockchain. So this is what the typical blockchain things. So the user basically authenticate and then get into the system. Okay, so am I audible? There is a message that I received, my voice is breaking.
Yes, sir, audible, but why is too much high?
Okay, so can I? Okay, now it's audible?
Yes, yes.
Okay. So users, I'm part of some institutions, let's say IIT Indore. IIT Indore has a blockchain technology. Me becoming the part of that blockchain is basically permission. When institute authorities allow me to become part of that system, then only I can block. This is called permission blockchain. So these are the two differences. So the cryptocurrency that we talk in a while are basically two types. Some of them are open-ended, like the first one, permissionless thing, and some of them are indeed permission technologies. So Bitcoin and blockchain are two more or less associated technologies, but they are not the same. Blockchain is a technology which allows Bitcoin to operate. But Bitcoin is a currency system. So what is the so for example, if you take the banking example, banking system is a system which controls the economic transactions. But the relational database and the set of computerized code that is running is not the banking system. This is a technology. I can use that for banking system, I can use it for any other financial system, I can use it for any other institutions. So that relational database is a technology, and banking and the transaction that I do is an application. Similarly, blockchain is a technology which is a mean, and the Bitcoin is a system or a currency exchange medium. So that's the subtle difference. So since blockchain's first application is Bitcoin and one of the prominent application of the blockchain, so that's why we typically talk about Bitcoin whenever we talk about the blockchain technology. So what is it? It is not a currency issued by any institution. No government agencies in the world as of now has made Bitcoin as a legal tender. So Bitcoin is an idea. It's based on some cryptographic methods where the double spending problem is handled. So hence it is an algorithm. It is an open source project. Anybody can download, and even the source code of the Bitcoin is available, so you can scrutinize that for its correctness. And it is not a Ponzi scheme where you might have seen some people come with this site, yeah, you make 10 people membership, you will get, you move to one position higher, and if you, those 10 people, you bring another 10 people, you will go to another level. So when 100 people are below you, then you will move to one. So similarly, the kind of Ponzi schemes run. So once you make 10 people, they say you sit quiet, and then they run the system. So unfortunately, it doesn't work that way. These are fraud schemes. So Bitcoin is not such a scheme. It is based on sound cryptographic technology, and there is no scam that is happening. So using the Bitcoin is a different things. What I am talking is purely from the technology perspective. It's actually not a Ponzi scheme. So it has a distributed database like the banking system, and it's based on distributed peer-to-peer digital currency. Let's come back to this term, peer-to-peer, and one is client-to-server application. So the traditional banking system, the way it operates is on the client-server model. And the second one is peer-to-peer model, where X want to send money to Y, X and Y directly interact. There is no intermediate system in between which controls the transaction. That is what the peer-to-peer. We'll come back and see what is P. And there is no physical currency, and it's not backed by any gold or silver. So that's the, in a nutshell, Bitcoin is. But two things, one need to give away. It is a revolutionary algorithm based on sound cryptographic technologies. As an open source project, anybody can scrutinize it, and it is not a Ponzi scheme. So what is the blockchain problem in this with respect to Bitcoin actually solves? So this is a snapshot taken from an original paper written by a pseudo author called Satoshi Nakamoto. Satoshi Nakamoto, we don't know who he is, maybe set of people. But when the first paper appeared in the name of Bitcoin, it actually came with this, the name Satoshi Nakamoto. What he said is, what is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need for a trusted third party. So this based on sound cryptographic proof, allowing any two willing parties. I am willing to transfer rupees 100 to some other person. I am willing, he is willing to take that money. Only we should be involved. There is no other person in between me and him. That is what the third party is. So in the traditional system, the bank is the third party which controls our transactions, what I want to send, what he wants to receive. That what Satoshi Nakamoto wanted to get rid of. So bank is no longer there in the picture. Two parties which are based peer-to-peer, this is called one-to-one. Transactions that are computationally impractical to reverse would protect sellers from fraud, and routine escrow mechanism could easily be implemented to protect the buyers. In this paper, we propose a solution to the double spending problem using a peer-to-peer distributed timestamp server to generate computational proof of the chronological order of the transaction. That's what it is. So in the order in which transactions are done, everything is recorded and the trail of the money is maintained. But at the same time, there is no mechanism where the money is disappearing from the system, and there is an inherent protection against the double spending problem. So if I have $10, I should be able to spend only $10, not more than that. So this protection is already there. So this difference you understand. X to Y transaction is happening, only those two are involved, and I should X should be able to send money to Y, and there is no intermediate third party which controls the transaction. So in traditional system, what bank was doing is no longer there. So and it is based on pure and sound cryptographic technology in the back end. So what does it mean? Blockchain is completely decentralized. There is no one single point of failure. So like the banks, if let's say all data centers of the SBI suddenly are destroyed, everybody's money which is there in the bank account will disappear. There is no trail of how much money kept. Although precautions are taken to protect it, but the entity which controls everyone else's money is actually the bank. SBI is the one who is master, which is keeping all the everybody's records of the data. So this we should want to get rid of. This is centralized. So decentralized is I should be able to see who is doing what transaction. Of course, work money karenge. So such a transaction happened in the system. So this is decentralized. And persistency means once a transaction has happened, it should be there forever. There is no way to erase that transaction from this. Hello. 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 Am I audible? Hello. So is there a lot of disturbance in the middle or what's happening?
Yes, sir, it is lot.
Okay.
There is lots of disturbance.
Okay. Let me connect with another I'm having some issues with the Wi-Fi. Let me join with another one. 1 second, I'll pause for a second and then I'll lock it. Hello.
Yes, sir, you are audible.
Yeah, okay. Yeah, fine. Now it's better. So this is what okay. So this is what talking. Blockchain is decentralized and it is persistent. So once a transaction is made, it's actually not erasable, and there is an inherent anonymity. So we'll see this point. So basically, somebody is in the system because everybody's transactions are available to everyone else. So privacy of mine, who is spending, who is doing the transaction, that should be protected, and the entire system need to be auditable, so that the ecosystem is neat and clean, and there is no trail of the money which is coming. Basically, the double spending problem is not appearing. So how does Bitcoin, using that blockchain as a technology, you make use of that? It's a digital distributed currency. There is no central monetary authority which controls the transactions. No one controls it. They are not printed, instead it is mined. So we will come to that point, what is mining, and it is enabled by peer-to-peer computer networks. So the advantages of the Bitcoin are, it is in cost-effective means, because there is no intermediary which control the transactions. It's all on a voluntary basis. Anybody who is willing to join, particularly the permissionless coin technology, can join it. And anybody who is willing to contribute something to the system can also contribute. That's why it is voluntary based service, and then it becomes cost effective. There is no data center, there is no staff members who is maintaining those systems which in the conventional system that are required, and it is an efficient system. But the transactions once recorded is available for all the time to everybody in the system, and it is safe and secure because it is based on sound cryptographic method, basically the public key cryptography based system. We will come to that point. So let's say this is what I was talking about as a peer-to-peer transaction. So here in this example, Peter is having a balance of $100, and he is giving some money to the James, which is having zero in its account. And basically, some bitcoins are sent from Peter's account to the James account or directly transferred. So there is no financial institution which is involved in the which is controlling the this transaction. So without the blockchain, basically the bank will come into picture. With the blockchain, it is only the James and the Peter who are involved in the transaction. That's the thing. So what does it mean as a double spending problem? So Peter has $100. So when he says $100 is sent to the system to James, only James should be able to receive $100. But the transaction trail is also available to some other person called Sarah. That Sarah should not be getting $100 as a money. So that's the double spending problem. So, but the details of Peter has sent $100 to James should be available in the system, even to Sarah to verify. That is what the open source and decentralized and immutable ledger essentially means. So this should not happen. $100 should not go to the Sarah's account. Only James should get the $100. So this entire ecosystem of Bitcoin is based on 3 layers. One is the cryptocurrency, that we talk about how the currency is handled and how somebody is making use of that cryptocurrency. And there is an underlying cryptographic protocol layer which enables this transaction to happen. And then there is a backend database system which actually maintains this record, which is called as the ledger. So let's talk about these technological details in detail. So how does the Bitcoin actually operate? So basically every user has got an account. So this in the Bitcoin terminology is called as an address. So just like an email address is there. So whenever some transaction is done, it's basically done with respect to that against that address. And so there are wallet softwares which allow to be installed and used. And when I'm using that software, it's actually it enables you to send and receive the money just like the email account are there. So anybody with private key to an account, so users have got a private key and they can use the wallet. So a private key actually might look like something like this. So the one that is shown lying in the below, 13 MCKX, so forth. So using this key, the accounts are validated and the transactions would happen in the system. And user identities are protected. So when I'm sending money, I'm sending to only this address, not actually to the person X, not person to Y. So inherently there is a danger that if I use this key, then the access to the account is also not possible. That money is not disappearing from the system, but it's not accessible to anyone in the system. So only when if I have, let's say $1,000 using this private key, only this private key, those $1,000 can be utilized. So if I lose this one, then that $1,000 is also not usable. So not usable is different from money disappearing from the system. These two things. So unique. So this is how the address is actually generated. This is based on something called electric curve cryptography, WTA system. There are two integers. There is a curve. X and Y coordinates of that curve are taken, which are 32 bytes numbers, and then these two are concatenated, and you run a SHA-256 hashing algorithm, and then SHA-256 is basically a message digest algorithm. So message digest algorithm basically is 32 plus 32, 64 bytes of the data is compressed, plus 1 byte of additional identifier is added, and then this is compressed into a short format, 256 bits of the data, and then on top of that to run the write and 160, compress that 256 bits into 160 bits, and those 160 bits will be actually along with that each 4 bytes checksum is added, and then 1 byte of identifier is added. That gives you this kind of key identifier. This is the key that is generated. So the wallet software that I am telling you is actually basically has inbuilt technology to generate this kind of a key, and then when you get into the system, is actually one key using this mechanism is generated, and using which you can actually do the transaction. So you should keep this key protected so that in subsequent cases, whenever you do the transactions, your money is accessible. So behind it, this is what actually happens. So this money, how does the other people actually validate this transaction? So when I'm saying transfer $100 from account X to Y, basically using these addresses at the bottom. So basically I'm saying using this address to transfer it to any other address. So that address is also a similar, has a similar structure. So what does it happen? So everybody in the system listen for these transactions, and they maintain a blockchain and listen for new blocks that are advertised. So when I say initiating some transaction, a new block is generated, and that is broadcast to the system. Everyone who is part of the system is actually listen to that and to decide whether this transaction is a valid transaction or not valid transaction. And you can assemble a candidate block and find out that makes your block valid. So miners actually do, there is something called the norms and verification, and that miners will, when I do a transaction $100 transfer to my account to X account, so everybody in the system, basically the miners will say initiate a verification process whether the $100 that I am sending is there in the system. So when the miners say yes, then the money transaction becomes valid, and the other person will actually get the money. So that is the role of the miner. Basically, they are validating the transactions that are initiated in the system. So when I initiate the transfer, I create a block, and that block is basically accepted or rejected. When miners say this is not a valid transaction, then that is rejected. That will not appear in the system. And so when they say yes, this is a valid transaction, then the transaction is accepted, and that is recorded in the ledger. So what do the miners get? They get some profit out of this transaction, just like these valid transfer. So for example, if they use Paytm and other things, so what they actually get when I transfer money from X to Y account, they actually get to, so when I buy using their valid service, they actually get paid some amount of money from the seller, and as part of that they actually make use of that. So that's the profit. Similarly, the miners also get, whenever I do a transaction, part of the money is actually taken by the miners and they get profit out of by validating these transactions. So what do actually miners do by doing the validation? This is one picture which is actually showing a couple of laptops and a desktop. Way back when in 2009 cryptocurrency, this Bitcoin came into picture, a lot of users started doing this mining activity. So some kind of GPU based, GPU graphical processors they assembled and then started doing validation of the transactions that are blocks that are used in the system. So this is done by solving some cryptographic puzzles. To solve those cryptographic puzzles, they assembled this kind of hardware and then use it. This is one of the earliest systems. Now today's systems are completely different. So this kind of homemade systems were actually users built so that they validate the Bitcoin transactions and then earn profit from validating the transactions. So, but today there are no systems like this which actually help you to earn Bitcoins or the money by doing the mining operation as of now. So the mining, because the computational puzzles that we solve required lot of computational power. Using these homemade computers residing in one room, you cannot do validation of such transactions because the things are getting complex and then these computational powers are no longer sufficient enough to solve the cryptographic puzzles that are there in today's Bitcoin system. So what is the alternative? The alternative is system manufacturers basically build some kind of very heavy computational power equipment specifically meant for only mining the Bitcoins. These are specific customized hardware things that are built. And alternatively, people have built data centers to just to do the mining activities so that they can earn profit by doing the mining operation. So anybody who is having money can set up a data center and then become part of the open ecosystem and do the mining activity and earn profit. And the third set of operators have to build a kind of pooling system. So let's say I have one computer, you have one computer, somebody else have one computer. So I devote some part of my computing power and you devote some part of your computing power. And the third person will also devote some part of the computing power. So this is a distributed pool of computing power available to do the mining activity. All of them collectively solve the cryptographic puzzles and then earn the money based on the quantum of the computing power that I devote to the overall mining activity. I get my share of the profit. That's how they actually operate. The first thing is you specifically build mining equipment by the manufacturers. Second thing is there are specific data center built to do the mining activity. Third thing is people voluntarily coming together, generate a pool of the systems and then all of them collectively solve the cryptographic puzzle and then they share the revenue that is generated proportionately to whatever they have gained. So in 2009, one could mine around 200 Bitcoins with a personal home computer. That's the quantum of the cryptographic puzzle was so easy to solve. In 2015, it would take the same Bitcoin one mining activity. So if I have one desktop, it took around 98 years to just mine one Bitcoin, meaning that it became so complex. So from 200 Bitcoins from one personal computer, from one Bitcoin in 98 years, look at the level of the difficulty that has come just in 5 to 6 years. So in today's time, there is virtually no money to be made from doing the home mining unless you are part of a larger pool of systems, some several thousands of these systems coming together. So that's the level of difficulty, it's increasing. So today's Bitcoin miners can compute over 5 exahashes per second. Basically, validating that hashes is the mining activity. I'll come to that point in a minute. So basically, miners are generating a valid hashes. So 1 exa per second is basically million of SST2 and 56 hash operations every second. That's lot of computing need to do. So miners solve computational puzzles to validate the transactions. So basically you might have seen this puzzle activity. What does it mean? So if you visit some website, you might have seen. So they will ask you to verify whether you are a bot or not a bot. So they might show some captcha and then ask you to enter it in a text box. That's the puzzle. So if you are able to read that and then enter correctly, then only let you do the to visit that site or send an email. So this idea was basically first proposed by email and then it took into different website and then now it is into cryptographic monetary system that's in the Bitcoin it is used. So the miners has to basically do it's similar to that. When you have to solve it and then the transaction becomes valid. So how does the blocks in a blockchain actually look like and what is that the miner do to validate the blocks in this system? Let's say out of nowhere Alice has got $500 in his account and Alice gives $50 to Bob and the third $30 is transferred from Alice to Sandy's account and another $40 Bob is given to Sandy. These are set up transactions. Each transaction is now think of that as a block. One block is out of nowhere some $500 come in account of Alice. Maybe you will go to the bank and deposit. You can think of that way. And the bank doesn't ask from where you are bringing that money. As long as you are depositing currency, it's okay. And from that account, Alice is giving $50 to Bob and 30 from Alice to Sandy, 40 Bob to Sandy. These are the transactions. You can think of these as 3 different blocks in the blockchain. So at the end of this transaction, because Alice give 50 and then another 30, so he should be left with $20 in his account. And Bob has received $50 from Alice and he has given 40 to Sandy, $10 is left in his account. And Sandy has received 30 from Alice and 40 from, and there is a $70 money that is left in the Sandy's account. This is the consistent state in the transaction. So how does the blocks, equivalent blocks in the blockchain look like? The very first transaction is number 1 and this is a new transaction and it is telling credit $500 to the Alice account. This is one block. When this block gets validated, the subsequent transactions which are using this $500 will be based on this. The transaction is basically broken into 2 things. One is, what is he doing? Alice is transferring $50 to Bob. This is the second block. This is broken into 2 sub-transactions. One is transfer $50 from Alice to Bob and the remaining $450 I transfer from Alice to Alice account. That's the new money that is left in the Alice account. So $500 were there. That is now 2 new transactions based on that first transaction. So you can see used here is the transaction number 1 and new transaction that is created is transaction number 2 and 3 and the money dollar is 50 and 450 respectively and from to one is Alice to Bob, the second one is Alice to Alice itself. Both of them are using the first transaction as a reference. So what it means is, in this case, the second transaction and third transaction is conditioned on the first transaction. Only when the first transaction is valid, the second and third transactions are valid. So who does the validation? The miners do the validation. And in turn, what they get by validating this transaction, they get some share of the money from the system. And in the third place, LIC is sending another $30 to Sandy, and $40 is transferred from Bob to Sandy's account. This is the transaction number 4. New transaction $30 sent from LIC to Sandy, and since LIC is having $450 by virtue of the previous block, this is block, reference number 3, and both of these transactions are conditions on the reference number 3. Using the reference number 3, transaction number 3, 4 and 5 are new transactions that are created, and 30 and 20 are now transacted to LIC to Sandy's account and LIC to LIC's account itself. And the 6 and 7 similarly are transferring $40 to Bob to Sandy, and the remaining $10 of Bob account to Bob to itself, because Bob has received $50 from LIC. So these two transactions 6 and 7 are conditions on this transaction number 4, which is validated in the second block. So what it means is, every new transaction that is initiated is conditioned on the one of the previous transaction. Only when that block is validated, this block is now valid for the miners to validate. So if that transaction becomes invalid, then this transaction will also be invalid. So what I am saying is, there is a sequence of many transactions that is happening. So the validation of the next block is conditioned on the previous block. So only when that previous block is validated, the new transactions are allowed to take place. So this is how the blockchains actually work. So, so in terms of the money transaction, you can say this. Whatever the transactions that happen, what is actually left in the equation. So at the end of this, you can actually check Bob is left with $10 by virtue of the transaction number 7, and Sandy is left with $70 by virtue of transaction number 4 and 6, and LIC is left with $420 by virtue of transaction number 5. That's what we wanted in the previous, typically wanted in the account. This is how the blockchains actually work. So one block and next block and network so forth, it's actually a chain that is maintained. Each block has a reference to the previous block, and then that sequence continues. So let's look into, come again, somebody had a question. Hello? Hello?
Yes, sir.
No, voice is no audible?
Sir, audible but not clear. The background noise is good.
I think I'm having some... Okay. So I'll try to come closer to the mic. Noise in the background.
Yes, sir. Yes, sir.
Yeah. Now you see?
No, sir. It is not clear.
Slightly better? Okay. So I can close to the mic and speak. Okay. Yeah, so what I am trying to say is, every new transaction that is initiated in the system is based on, conditioned on the validity of one of the previous transaction, and the sequence goes on. So the new set of transactions, now the Bob is able to initiate transactions only for the $70 that he has in his account, and Sandy is able to, Bob is having only $10 now, so he is able to initiate transaction for only $10, and Sandy is able to initiate transaction for the $70 he has, and so forth. So this sequence of events or the transactions are assembled in series called as blocks. So you can see one block to another block to another block. So this continues as a chain. So at some point of time, two different transactions might be initiated by different users. They appear as a fork system. So in this case, this color code actually tell you this. From green color, one block is the one which is the very first block that is created in the system, and then the next block is the series that is initiated into black color. and the next two blocks, one is with purple color, another one is the black color, and the black color sequence is the one which actually continues to grow, and the purple color block is actually stopped in the middle. So similar things happens in the system because these are all distributed systems. A lot of people are trying to mine the blocks that are newly initiated. So for example, if I have some computing power, I can also validate some transactions and then broadcast a block. You can also do the validation and also broadcast a block, and this block and that block mine and reverse come into the system. So whoever advertises for the first time, they will win, and that transaction will be taken as a reference for the subsequent transactions that are growing in the system. So here in this case, the black colored transactions get wins, and subsequent transactions are growing with respect using that transaction. So the purple colored transaction is momentary, it is there in the system, but it is not valid. So that will be killed, that thread will not grow further. This operation is called as a fork operation. So why fork operation happens? Because miners are competing to validate the mining. So it is, if I am able to compute it faster than you, I will win. If you are able to compute it faster than me, then it will win. Whoever validates for the first time, their transactions will be first recorded in the system, and using that transactions, so somebody else will further initiate some other transactions, and then that keeps on going. So that is what the blocks look like. So, but these blocks are dead. The blocks are not disappearing from the system, but only thing is they are not used for any other validating any other transaction. At any moment of time, only one thread is growing, which is valid. So there may be, since this is millions of users are there are actually lot of threads that might be created, but only one thread after a while will actually survive and keep growing in the system. That is what the blockchain typically look like. So what does the miners do, and what is exactly there in the blocks? Let's try to understand. So these actually there are three things that there typically in the block. One is something called the hash of the previous block. That is the entire block is taken and then hashed, and you compute the hash and then attach it to the block. And then there is a random number which is there in the form of a nonce, and then there are some transaction details. So for example, if you go to this slide, whatever the details are there, 3 previous transactions, 4 the current transaction, $30 allies to Sandy is one. These are the actual transaction details, and all of this information is there in one block, and also the one random number that is there in the block, and then the hash of the previous block is also there in this block. These three things are taken in one go. So this transaction details, whatever number of transactions are there in one block, those transactions plus one random number plus the previous hash of the previous block is taken, and then the new hash is generated. Now the goal of the miner is to validate hash. So what does it mean? If I advertise one set of transactions and keeping them in one block using nonce, so this entire thing is actually the hash is computed. Now for miners activity is to find out what is the nonce that is used to the transaction is fixed. Whatever amount of money that I want to transfer from X to Y, Alice to Sandy, Alice Bob to Sandy, all of these are fixed. And the previous block hash is also fixed. That is not changed. Only thing that is here which is allowed to be guessed by the miner is the nonce. So by systematically generating nonce from 1, 2, 3, 4, so forth, there is one number which actually validates this. So once that a miner is able to guess that nonce, the block is validated. So the sequence is basically this. I take the previous block nonce, in this case block n, there is some randomly appearing number in the black color on the second vertex sequence, and then there is a nonce like 25630322261. This is the random number. And in transaction data is the these transactions, the previous reference transaction, the new transaction number that is created, and the quantum of the money that is transferred from Alice to Sandy's account, Alice to Alice's account. This is the transaction data. That is the third component. And then the hash value generated, which is in the red color shown here. Some zeros in the first row, then 0274 CD, something like this. And then A3 up to end. So this hash value is taken as a reference for the next block, which is in block n plus 1. Same colored hash value is also shown in the third column in this diagram. And similarly, another random number is used by the initiator of the transaction, and depending upon to whom he is sending the money or sending the money, the transaction details are there, and then another hash value is computed. So like this, the sequence is actually good. So the job of the miner is basically to identify the nonce that is used to generate this transaction, and once he is able to guess the nonce correctly, the block is actually gets validated. So this is the entire operation is based on some cryptographic technology. This is public key cryptography. This is also called as asymmetric key cryptography. So what does it mean? Anyone can encrypt and send it to the recipient. Only the recipient who has the private key is able to do it with the money. So blockchain actually relies on this safe cryptography, and it actually ignores the attack. We will come to this point, why it ignores the attacks. So there is a reason to ignore the attacks. It doesn't mean that attacks are not possible, it is possible. So what it simply means is, if I am able to generate the attack on the system to support the entire ecosystem, I will end up investing more money than that I actually make out from supporting the system, which is not worthy of doing. That's what the works and relies on. So understand this thing. This is based on public key cryptography, which is also called asymmetric key cryptography. So anyone can encrypt the data and send it to a recipient. Basically, in this case, it actually means that anyone can generate a block and advertise it, and the only recipient will get the money, and the miners will be able to validate the transaction. So how does this look like? So the signature, I have message yum. Message yum is the transaction details that I am incorporating in a particular block, and then there is a key that is involved to sign the message, which is in this case is the public key, and a signature is generated, and then that is advertised. So what is advertised? The message yum and also the signature concatenation of these two are advertised to the system. And anybody who is having the pure public key will be able to verify whether this is a valid transaction. So I use the secret key to encrypt and sign the message yum, and the message yum concatenated with the signature is taken together, and the public key used to verify that message. So the required properties is anyone with the public key should be able to verify the message, which in this case is the PK. And unforgettability, anyone who knows the public key can, and an earlier signature of some other message should not be able to generate a valid sign for some other message. So this is the cryptographic property. So I need to use such a crypto system which does not allow to generate another valid signature for another subsequent message using it if I have a possession of some other signature of the previous message. At the same time, everyone in the system should be able to verify using the public key. So there are many algorithms out there which are able to do this. These are called the hashing algorithms. So let's go and see what are the properties that are required of such a hashing system. These are also the digital signature. So digital signature or hashing is a one-way function. which maps an arbitrary data of arbitrary size into a fixed size output. When I say SHA-256, it generates 256 bits of the output irrespective of what is the size of the input that you give. So irrespective of what is the size, in this case, the transaction detail, whether it is I am sending to 1 people, 2 people, 3 people, doesn't matter. So once one block is initiated, a bunch of transactions are there here, and then those transactions become one bunch, and then that bunch irrespective of how many I should be able to generate only 26 bits of the output. That's the property of the function. And it is not possible to reverse the computation. Given the signature, I should not be able to decode what is the transaction details. Signature is just a proposed. I have the message here and I am able to compute the hash. But given the hash, I should not be able to decode the message itself. Neither I am able to start another message which can get into the same hash value. That's the property, that is the signature. If hash is transferred securely, then changes can be detected. So that's the digital signature property. So in another terms, so given if I am the one-way property is if I am given the message y, finding x such that h of x is equal to y is easier to do. So when I pass that message and also to the algorithm, h of x is easily find out, but not the other way around. If I h of x, it's not possible to find out the y. Second property says the pre-resistant. So I'm talking about the hash that is generated here. So you can think of this. After taking the previous block, in this case, the red colored hash that is generated, if I am given this piece of information, I should not be able to find out what is the transaction details that are incorporated in that block. But what I am able to find out is, given these three components, I should be able to generate this red color text, or this yellow color text, or this blue color text. That is what I am saying here. So pre-image resistant is if the given x, which is a hash value, find some other image which is y is not equal to x such that h of x is equal to h of y is not also possible. And it is also collision resistant. So y and x are given, and y is not equal to x such that h of x is equal to y is not possible. So there are three properties or required properties of a hash function. So it is one-way function, map an arbitrary size data into an fixed size of the data. That is property. And given that signature, I should not be able to find out the other way around. So given one hash value, I should not be able to find out another message which is actually generating the same hash value. If I am given y and x together such that in x is equal to so h of x should not be equal to y. This is actually not practical to find out. What I am saying is, arbitrary size messages transferred into a bit size 256 data, and the message size is arbitrary. There are infinitely many inputs. The domain is infinite, but the range is fixed, which is always 256 bytes. So how many different values that you can generate with 256 bits of data? There are only 256 different values that are possible. Since the domain is infinite and the range is finite, more than one messages in the domain will actually map into one possible value. But yet, if the hash function is good enough, is doing a good job, so that should be collision resistant. So as much as possible, given two arbitrary message size, they should be mapped to two different values. That is what the collision resistant property actually says. So any hash function that is used in this system should be able to possess these three properties. There is one way, this is collision resistant, and then this is image resistant. and at the same time the property of unforgettability is actually maintained. So these three properties are requirement of the hash function that is used in the Bitcoin and for that matter blockchain technology. So this hash function, basically what I'm doing is I'm taking a chunk of the messages, breaking it into an equal sized size messages and then passing it to a series of functions and then keep passing it into a series of concatenating, and then at the end of this I generate the size value, the hash value, what the blue color text in this diagram is showing. So that is what typically the hash function do, and that is the job of the miners. These hash functions are usually stored in a special representation called as a Merkle tree in the blockchain. So there is another session that's actually particularly talking about Merkle tree representation and why it is used and so forth. So I'm just doing it from the to save some time. So just as I said, let's recap what is the Bitcoin and blockchain is doing. So Bitcoin is basically a distributed currency, meaning that the transaction, the ledger is available for everyone, and everyone keeps a copy of that ledger. So if I become part of the Bitcoin, I can choose to download the entire ledger that is out there as of today. And so it is the choice. It is based on some cryptographic algorithms, and the miners do the validation of the blocks. Every transaction that is done in the system is actually maintained as a block. These blocks are some kind of, you can think of it as a linked list. One link to another link to another thing. It keeps on growing. At some point of time, because miners are competing to validate the block, so there might be ports in the system, or two different transactions are initiated at the same time. Using that, there are ports in the system, but ultimately only one thread is recognized by the entire system, and that thread actually grows, and the ports, other one gets killed and they don't survive and they don't grow any point of time. So this is the summary of the Bitcoin and the blockchain. So what is the underlying technology that is involved in this? This is because distributed system, the consistency of the system is an important activity, and the scaling is an important activity. What does the consistency means? Consistency means money is not coming from outside nowhere. It is not increasing what is there in the system without any purpose. It is not increasing. It is not decreasing without any purpose. So whatever we had in the banking system, if I have $100, only $100 are there in the system. Only $100 can be transferred from one to another person, another to X to Y to A, B, C, whatever is going. Only that money is circulating in the system. So that is the consistency. And scaling is because there are a lot of people involved. So the process gets bigger, and anybody who is willing to join should be able to join, and it is distributed because everybody is able to download and become part of the system. So what is the threat to this distributed system to maintain this consistency and scaling? So continuity, anybody initiating transaction at that time between X to Y, P to Q, A to B, L to these things are happening. So maintaining consistency is an important aspect for the validity of the entire ecosystem. So what are the threats? So if I say, if I have $100, if I say transfer $100 from my account to somebody else's account, so only that $100 is transferred. The message goes to everyone else in the system. So what are the possible points that can happen? This message, what I am saying, transfer $100, may get intercepted in the network. Somebody else might be blocking this message. This is the first threat. And there is a threat that this message gets modified. So I need protection against this modification. And in the middle, somebody else, when I am saying, I'm not saying anything to transfer from my account to somebody else's account. On behalf of me, somebody else in the middle might be injecting a message to saying that Neminath is saying to to transfer some $100 to somebody else's account. This is the third threat. And there is a fourth threat that the nodes might get disconnected randomly. Even that, so whether the system, this distributed system can survive and still operate correctly. So what are the possibilities? Message gets intercepted, so transaction gets intercepted, message gets modified, I need protection against that. False messages are injected in the system, I need protection against that. And the nodes gets disconnected, and in spite of that, can this system work and can scale and can still maintain the consistency. So we need guarantees against functioning under all such adversarial conditions and conditions. If some nodes gets disconnected, the remaining set of the nodes that are still connected will be able to trace out what is the left out money in the system. And if some messages are get intercepted, so either the validity of that message which is intercepted should not be reflected in the system, so that whatever $100 I have can still be traced back. If my message what I am sending is I am saying transfer only $10 from my account X account, so that message should not be modified. If it is modified, the system should not recognize that message from accepting that message. And if somebody else is falsely fabricating a message and broadcasting on behalf of my name, that should not be accepted. That's the third properties. And in spite of some random number of the failures, the system will be survived and it should be working. That's the consistency. This is nothing new in this distributed system. The distributed system that you take should have the property. So the parts are avoidable. So in spite of those parts, the system should be able to work consistently. So this Bitcoin ecosystem and the underlying blockchain technology facilitates against functioning of the system in spite of all these adversarial activities. So I said this is actually working on a peer-to-peer system. So peer-to-peer system is one-to-one connectivity, and client-to-server model is another kind of the activity. So peer-to-peer systems are designed to work in resilient against the failures. So I just give an example. If we have used the BitTorrent or torrents for any point of time to download some movies and all, so how does it work? Some movie is there, or one file is there to be transferred. So replicas of that files are there randomly distributed in the system. When I query for one initiate download for one particular movie or file, so the system will be able to find out who all has the copies of that file, and you get to watch the player and then started downloading from that player directly to your system. So this Bitcoin or blockchain technology is also such a kind of based on such peer-to-peer networking technology. So what does it mean? When I am initiating the transaction, only I and you are involved, but only we take the support of the miners to validate the transaction that I and you do. So once that transaction is validated, then everything else in the system recognize that system. So to do the transaction, I don't need the support of the system, but to validate the transaction, I need the support of the system. That is the miner's activity. So what is that? To validate, validation is the whole system is recognizing that transaction. I am transferring $100 to my account to your account. This is happening on peer-to-peer basis. I initiate one transaction, put it in a block, create a block, advertise that into the system, I send that one to you also, and you receive that block, your money gets updated. But to recognize that $100 is deleted from my account or debited from my account, and $100 is credited to your account, you indeed have $100 in your account. To recognize this, I need support of the system. But to do the transaction, to transfer money from my account to your account, I don't need the system. That's the difference. So this blockchain is basically based on peer-to-peer activity. So peer-to-peer transaction. So one is into other. So this is inherently resilient to build. What I mean by that? If you go back to that example of the current, so if I set on my system, I have some movies in my local system, somebody else who is interested to download that movie, if I am not online, so the system still continue to work, BitTorrent still continue to work. So whoever else is having that copy will be able to serve the end users. So that's the end result. So what I'm saying by this is, today let's say I am part of the Bitcoin network, our blockchain technology I am having, and tomorrow I decide to walk out of the system. Since I did some transaction in the past, that money trail is still there in the system. The remaining, collectively all other nodes that are remaining in the system will be holding that transaction details, and the money trail that I made, that I belong to some transaction is still there, and by virtue of that, they are able to validate the future transactions that are generated in the system. That is why they are resilient to failures. So today, person X is part of the blockchain technology or Bitcoin network. X does some transactions and they have been validated. Since the ledger is immutable, even X walks out of the system, that trail is still there in the system. The remaining set of nodes at that point of time in the network will be able to validate future transactions which are based on X's transactions in the system. That is what the resilience means. So all the nodes, this will tomorrow X is there, Y is there, Z is there, it really does not matter. As long as the set of transactions all nodes are able to validate it. Hello. Yeah. So is there audibility issue? I think so. Lot of audibility issue there. Unfortunately. Okay. So I said the survivability is issue. So what does it mean? So all the transactions, future transactions are based on the previous conditions of the previous transactions. The miners do the verification of the blocks. So how do they verify? They usually guess the norms that is there in the transaction blocks. So in this diagram, the second component, the first component is the hash of the previous block, and the second component is the nonce that is used, and the third component is actually the transaction details, and using these three components, the new hash value generated. So this hash value is broadcast. I am having the access to the previous block hash value. I am having access to the transaction details that are made. Who is transferring the money? Who is transferring the money? Now to generate this, to validate this function, somebody else who is doing the mining business should be able to generate the hash value that I am generating by guessing the nonce value. The second component is not advertised to the everybody. I advertise the transaction details. I advertise the hash value that I generate. The third component and the last component, which is there in the red color and the yellow color and the blue color, is advertised. When I am advertising who is making the transaction, to whom he is sending the money, that details are available, and what is the new hash value that is generated is available. By using these two components, the miner job is to guess what is the nonce value that I use to generate these two values. And the hash of the previous block is anyway available to the entire system. So that is what the miners actually do. So how does the miners do the validation? They start guessing the nonce value. So let's say the message number 1, by putting the nonce value as 1, you generate one hash value, see whether this is the hash value that I advertised. Put the hash number 2, nonce value is 2, and generate another hash value and see. And keep on doing this when the correct hash value is generated, and that hash value, when it matches with the whatever that I have advertised, some miner is actually able to validate the transaction, and then he actually, once he validates, he advertises, and then everybody else in the system is actually able to accept the block. So that's when the transaction is. This is equivalent to the commit operation that was happening in the conventional banking system. This is the job of the miners. What the miners do? Out of three things, one is the transaction details, and second one is the nonce of the previous block, and the third one is the nonce of the block that I am generating. One component is not known, which is a nonce. The job of the miner is to sequentially substitute value for the nonce and then keep on generating the hash values, and once you find the correct hash value, that would be the, when you use the correct one, that when you will be able to generate the correct hash value, and that's when the transaction gets validated, the block gets validated. That's the proof of the work. So how does as I said, in 2009, we were able to mine 200 bitcoins by using one computer, but in 2015, we were able to generate one bitcoin, it takes 98 years, I say. So what is that? It is becoming complex. It is becoming complex because the size of the nonce is getting increased in the underlying blockchain technology. So transactions in blockchain basically has a list of transactions which has inputs, and it generates a list of transactions as output. And these transactions have some quantum or amount of the data, and then the recipient address is there. So somebody has turned on his mic. Can you move, all of you? There is a lot of noise in the background. Is it? I think it's the voice of Sahil Hussain. Can you please mute yourself? Sahil Hussain. Yeah. Sahil Hussain, if you are here, can you? Hello? Okay. Are the administration? So each transaction is in a block, and it has got a set of inputs, and it generates set of the output, and in that transaction there is a quantum of money to be transferred, and the money is transferred to the recipient's address. These all things are there. So how does it look like? The input money, that basically the previous transaction based on which this transaction is referenced, and then the new transaction number, that is the output number, and some transaction in fact be conditioned on more than one previous transaction. So for example, here transaction number 1 is there and it is generating the output number 5. Transaction number 2 is also generating number 5, and the transaction number 3 is taking these two as one input and then generating some other output 6 and 3. So in the process, some quantum of money is also taken by the miner, that is the piece for the miner who is validating the transaction. So the challenge, the blockchain for the consistency and the survival, the actually data between performance and the security. So because several miners are actually competing to validate the transaction. The moment I advertise one block in the system, all the miners that are out there in the system are actually competing to validate those transactions, and the one who is able to do it for the first time would be validating the get the commission out of validation. So since the other details are available, and there is an inherent security threat or the privacy breach in the system, who is generating the money, who is actually utilizing that. So blockchain today's as of today is approximately 1 MB. It is not directly, but approximately it is 1 MB. So every block is 1 MB. So even if I do a small transaction, so 1 MB data is consumed. So this since the ledger is completely kept since from the day one, so the entire data is bulky in nature. So the Bitcoin's database as of 2017 is 2 terabytes, so it's exponentially growing times. So and the second thing that I did, the transactions are happening using the private keys being used. So if the private key if I lose, then the entire money I am not able to utilize. So again, understand the difference. The private key is only enable you to use the money that is there in the system. It is not required. That doesn't mean that money disappear in the system. It only means that it is not usable from the system. So it is something like that. So you think of this case. If I go and deposit some money in the bank, and if I'm lost the user ID and password to my account, and if I have left to two other documents to validate this is my money, so bank will keep that money itself. It is not accessible to me, but it is there in the system. So they might have some other mechanism to how to utilize that dormant account money after a few years, it will transfer to some government account or something like that. That's a legal issue. But what I'm trying to say is, if I am losing the private key to my account, which is an alphanumeric number, that money which is there in the system is no longer able to be utilized. But that money is not disappearing from the when it is maintaining the consistency. So even from the minus percentile, a lot of computing power is required to validate the transaction. So that's why it's becoming very, very heavy. So the ledgers actually maintain the blocks in the database, and everybody who is part of the system will be keeping a copy of the so all the blocks are available to all the people who are there in the blockchain, particularly if it is open permissionless blockchain. If it is permission, then it is available to all the people who are there in the who are allowed to this. So with appropriate permission, you can actually control the visibility of the transactions. So that's how the ledgers actually are maintained. So remember, ledger is available for access to everyone else in the system. So by distributing this transaction, everyone else agreed to some of the money, whether the person X, Y, whoever is transacting, is actually coming to some consensus in the base. So what does that mean? So just because of the distributed nature, I have a local copy of mine, you have a local copy of yours, third party also have a copy of yours. So when I am initiating a transaction, that transaction is broadcast into the network. I receive a copy, you receive a copy, third person will receive a copy. So there is an inherent delay in the when I receive a copy, person X advertises, when I receive a copy, when third person receives a copy, when fourth person receives a copy. So I am operating from the local version of whatever I have received so far. You are operating from the version whatever you have received so far. Third person, fourth person, 100% is operating from whatever you received. So in this system, because of the distributed nature of the and the broadcast nature of the transactions, everybody is bound to operate from the local copies which can be momentarily inconsistent in nature. So at point T0, I initiate a transaction, but the T0 transaction received to person 1 at T1, and the same transaction is received by person 2 at time T2. And same transaction might be visible to person T3 at time some other time at time T3. All of us, person 1, 2, 3 have an inconsistent global view of the transaction. But even if the view is inconsistent, because I am operating from my local copy, I am still trying to validate the transaction. So I should be having some guarantee that even if I am having incomplete consistent view, I should be able to come to some consensus. What is the consensus? Agreeing on, globally agreeing on whether this block is valid or not, this transaction is valid or not. if I am operating from instant V, so that transaction what I am having should not be valid. That is the distributed nature. So it might take some energy to synchronize that information, but that doesn't mean that I am agreeing to something which is not valid in nature. So a majority of the people out there in the system are veiling on some transaction. So I also able to afterwards be able to synchronize to that. And so that is what the 4 corporations that I showed here. So I am having some information of this system, and based on that I generate and broadcast one hope. So since everybody else, majority of them think that black color transaction is the one which is valid. So what I advertise based on my local information would become invalidated, and then that black colored one will be picked up. And at the simple job of mine is to take out whatever is the valid transaction and then continue from there to take it forward. That is what the distributed consensus is. Consensus means that the transactions in the block that are advertised is actually taken, and then everybody else is synchronized to what the globally agreed transaction it is. So this details, even if some of the nodes are failed at a particular point of time, still I am able to arrive at that consensus. This is something called in distributed system parlance called practical Byzantine fault tolerance. So Byzantine fault tolerance is some number of the nodes are not operating at this point of time, or they have permanently become faulty, or they are advertising because of the experimental fault, they are advertising giving the false notion of the details, and even then I should be able to invest to some value which is how much money is there in X account, how much money is there in Y's account, how much money is there in Z's account. That notion should be consistent and that should be valid. That is what the consensus and the Byzantine fault means. In spite of somebody else adversary giving you the false information, since there are millions of nodes which are having the correct information, eventually everyone else in the system should get the correct picture of the system, who advertised what and who initiated which block and at what point of time, and everybody else would be able to synchronize. So these are in distributed the consent portals is called on 3 correctness properties. One is called the non-triviality property. If I am saying a person having $100 in my account, and somebody else is saying I'm having $20 in my account. So the non-triviality property says either in globally, either in agree to 10 or agree to 20. Either what I'm saying is true or what you are saying is true. Both of them cannot be true at the same time. The momentarily, because of the distributed nature, somebody might think that what I say is true, somebody else might think that what you say is true, but eventually either what I say will become true or what you say will become true. And either my version will be invalidated or your version will be invalidated. And this conversion happens so quickly within a fraction of the minutes. So there is no global inconsistency that is happening in the entire system to support the entire ecosystem. And second property says safety property. So only one value can be learned, either 10 or 20, not both of them. And the third property is called the liveliness. Eventually one of the values is learned, correct or incorrect. So if the incorrect, it's very unlikely to happen because of the reasons that I'm going to tell in a minute. So if 10 is the correct value, it should be learned. But if the majority of the systems are subverted, which is very unlikely to happen because of the reason I say, but then also you should converge to some value which is the invalid value. So at any particular time, globally there is a consistent view of the system, but momentarily there can be inconsistent view of the global system, and after a time, while every node would be converts to the amount transaction details of the entire system there. So you can think of this as distributed concerns problem is some nodes are randomly connected with each other, like the one that I showed, and one of the node initiates a transaction by advertising the message details and also the hash value that is generated. Some nodes which is there in this will validate the transaction. They in turn broadcast that validating information to everyone else, and everyone else, because of the way they are connected, it might take a while to reach to the other end, but eventually they will reach to the other end, and then they all synchronize to the same global mean that was there in the system. That's the distributed consensus in the question. So and remember, for a moment I can have a global inconsistent wave, but eventually that will be synchronized to global consistent wave. And these three properties, non-triviality, safety and liveliness, will eventually make you commit to one of the value. You must have to exert one value, and all the honest nodes in the network will agree upon a value. So honest nodes, to subvert, if the majority of the nodes in this node, in this network are honest, then the honest value itself is learned. If the majority of the nodes in this network is not honest, then there is incorrect value will be learned. So that is the third property, liveness. Eventually one value is learned. It is correct or not correct. But to ensure only correct value is learned, we have some other safety mechanisms that are built into this system. So if you want to learn a honest value, so you must have that value generated from an honest node and validated by an honest node. So how does this system look like? So block numbers are there, 100, 101, 101. Somebody else, I am trying to compute valid block, somebody else is able to compute another block, whichever gets valid, that chain gets growing. And at some point in time, because of the inconsistency, you might have the fourth, and the fourth may momentarily grow, and then they become orphans, and the ones which are actually valid will keep on growing. And whatever is keep on growing will be there, which is survive, and then it keeps going. So that's the technology with which the blockchain operates. So let me summarize what I have discussed so far. So blockchain, one of the primary applications of blockchain is the Bitcoin, and it is based on some cryptographic measures, basically public cryptographic measures. So everybody in the system is able to generate the transactions and validate the transactions. It is transparent, and the miners will get share of the money by validating transactions. And this is based on some distributed consensus algorithms. And momentarily you can learn how to evaluate transactions in the system, but eventually, because of the way system functions, everybody agree upon a global consistent win. Money is not artificially generated and artificially assumed unless there is a valid transaction by it, and no one person controls the money that is generated, and no one person can destroy the money that is there in the system. Because it based on some cryptographic principles and distributed consensus algorithm, it's actually ensured the safety, that is the double spending problem is not there in the entire ecosystem. That is why the Bitcoin ecosystem works. So the job of the miners is basically to generate a valid hash value and then validate a particular transaction by virtue of regenerating the hash value. So I say this system is there. Then what are the blockchain usages? One killer applications is basically the Bitcoin. So there might be other applications which we'll see in a minute. So if I'm taking the same case of the Bitcoin, there are Bitcoin users. If I become part of the Bitcoin network, I become user, that is one user. There might be regulator who is controlling the economic, I mean, particular system. That might be a government agency or so forth. That might be a regulator. There might be somebody who is interested to make use of this blockchain technology itself. That might be a developer. And there might be people who are interested in doing mining activity and then producing processing operations. And the safety operations, because it is safe because this is transparent, the source code is available, and everybody can validate how the code is written and whether the cryptographic premises on which the entire blockchain technology itself is residing is functioning properly in future. And the future blockchain generator is also validated. So in order to support this system, the safety mechanism that is there in the system is basic. You should be able to, if somebody is going to try to support the system, needs to generate an invalid block and convince everyone else in the system the valid block. And Satoshi Nakamoto's argument is that this is not economically incentive to do it. So what I have to do, I want to support all of the users in the system. I need to have first invalid convince everyone else in the system to accept that as a valid.
Hello. Sir, not audible.
हेलो हैं किसका
Hello.
Yes, sir.
Is it audible now?
Yes, sir, audible.
Okay. So what I was saying is Bitcoin in some sense compromises the privacy of the end users. So here is an example. When my employer pays salary to me, it comes to a particular address that and on that address the subsequent transactions that are originating are all visible to the entire set of the users out there. And there is a danger that my employer can see how I am spending my salary, whether I am going to the movie theater or to some eateries, whether I am going to particular shops or forth. So this privacy is compromised. This is one of the negative side of the Bitcoin economy. So there are Bitcoin wallets also, which allow you to just like click and which allow you to download and become a part of the network, and they can also store these private keys secretly using encrypted safe symmetric key ciphers to protect them being lost in the system. So some of the possible attacks are stealing the bitcoins because they are distributed to everyone else as a copy. It is very difficult to erase the transactions from everyone else's computer. So it's actually not possible to support the system. And denial of service attacks, again, it is based on the same distributed PPT is not available. Okay, so I think now it's visible.
Yes, now it is visible.
Okay, yeah, a lot of disturbance. So the denial of service attacks, stopping from another user, for a momentarily can do it, but the entire supporting the entire system is also not possible. So Bitcoin as a medium of exchange can also be there. So what I'm saying is if I am participating in the Bitcoin, so there are some exchanges. So just like if I'm going to another country, like let's say I'm going to US, I need to buy currency of US dollars. So rupee is valid in Indian territory, and the moment I land in US, I need to use their currency. So similarly, Bitcoin, there are exchange points where you can go and buy. So for example, if I'm having money in Indian rupees, I can go to a particular exchange, and for a particular exchange value, they offer you certain Bitcoins. So once those Bitcoins are there in your wallet, you can do subsequent transactions. So just like the rupee and dollar money, the exchange value fluctuates every day, this Bitcoin value also fluctuates every now and then. So at a particular point at body the exchange value, you get the equal amount of money for that. So when you want to exit from the Bitcoin economy, you can actually again go to a merchant and then do an exchange. For a commission, they actually give you whatever the currency that you want. So some of the legal status in the cryptocurrency in India, it is banned to use cryptocurrency, but blockchain as a technology is actually encouraged to be usable. So because of this openness of the transactions that are happening, you can actually check how the trail of the money has gone from person X to Y to Z. At least from the regulatory perspective, whether this is legal money that is generated or not, you can actually check it out. Again, presentation is gone. I guess now it's visible. So some of the European countries also it's not legal, but some countries it is legal, like Nigeria, and surprisingly even US also allows the cryptocurrencies to be used. So one Bitcoin as of today is around 0.989 MB. That's what I said, approximately 1 MB. So this becomes bulky So every block is 1 MB, so there is a lot of disk space that is required to store the entire ledger information. And approximately the number of the transactions that are generated as of today is 3,56,924, and the market price for one big currency is approximately 11,000 US dollars. And if a miner gets validates one block, he gets 0.00024 dollars of money for this. This is some exchange rate over a period of time, how the one cryptocurrency Bitcoin is exchanged for certain amount of the data over a period of time. This is the distribution of the nodes that are involved as the part of the Bitcoin ecosystem. You can see bulk of the nodes are concentrated in either in US or in European countries and some Eastern countries in Japan and other Asian countries, and here and there sporadically distributed rest of the part, some being in India also. So this Bitcoin is a killer application, but there are other useful applications that can be developed using blockchain. So one of the applications that are people are talking nowadays is called the government asset management. So for example, the land records can be maintained using the blockchain technology, so that the trail of money, the piece of land which is out there is from person to X to Y to Z, when somebody is selling, whether he is the legal owner of that property or not, it can actually verify by using the blockchain technology. And you can also do the supply chain management, where the goods that is originated from a particular manufacturer is actually how it has moved, whether it is particularly the in fact manufactured by the seller who is the legal person. For example, somebody who is fabricating a false equipment and then claiming to be a valid thing will not happen in the middle. That kind of originality, authenticity can be originally checked by blockchain technology, and similar other applications are there in the So one of the other applications people are now talking about is Internet of Things, where the IIT devices can also be monitored using the blockchain technology. In summary, Bitcoin's success is remarkable in a short span of time. It gained the maintaining the anonymity of the end users, basically using an address. People can transact the over the distributed nature of the system, and it has got novel ideas, and it has got practical useful application. And the big takeaway is Bitcoin, by virtue of its existence and its popularity, created a bunch of passionate users, developers, and then an open source technology that can be applied in several other applications in today's. So that's all I have in my presentation. If you have some questions, I'm happy to take. Hello. Hello. To some extent, there is a question: can Bitcoin increase blackmailing users? There is an inbuilt anonymity that is built into the system. It is actually who is buying, who is selling, that information is not available as such to the person. But if somebody knows the to whom I am sending the money, so for example, if my employer knows to whom I am giving salary in terms of the Bitcoin, So that they can snoop how I am spending the money. In that sense, there is privacy invasion that I told. But as such, as of today, because there is complete anonymity that is built into the system, who is buying, neither seller's identity is known, not buyer's identity is known. So there is no question of blackmailing, at least as of today, unless this is accepted as a legal means of exchanging the currency and money transaction. I hope that answers the question. So, the one question, as if somebody blocks my hard disk and asks to ransom money. Every transaction that is there in the system is not only in your hard drive, but anyone else's hard drive. The blocks are there with everyone in the system. So there is no single point of failure. That is the time. The present time fault tolerance property of the Bitcoin blockchain technology ensures that even a part of the system, not only mine, somebody else's systems are disconnected from the system, then the whole money is there. So what might happen is, if they get hold of your wallet in the system through which you are accessing your account, then the money that is there in your account might be unusable. So that danger is there. So if my private key is compromised, somebody else might do a transaction using that private key and then might your account is as secure as long as you are able to protect your private key. Once you lose that, then the whole system you might losing the money. That is why these wallets that are coming up there are built security mechanisms to protect these private keys so that they are not easily lose. Okay. Any other questions? So if there are no other questions, then I thank you all of you for joining this TV program, and I also thank the organizers for the inviting me to give this lecture and colloquium. Thank you so much.
Thank you, sir. You are providing us
Thank
a
you.
very great benefits about your blockchain. So I think so many people are here and to thanks for you. And so many things related to blockchain.
Thank you.
Again, this session for that. Thank you, sir. It's our pleasure.
Thank you so much.
Thank you, sir.
Yeah, thank you.